Dear students, good evening. How are you all? I think you are doing good, right? So don't bother about this pandemic situation, right? Once again, I am requesting you try to utilize all these online classes, right? I will give you the assignment questions to you, and you have to make it complete, right? With good answers, right? Good diagram, explanation, all this, right? And you have to write the mid examination, right? So, based on the syllabus coverage for the mid, we have to write that mid examination, right? So that this mid should be in the online itself, right? So as per in the last semester, how we conducted that mid examination, like that also here also we are going to conduct the same pattern. Okay, you should be ready with for this mid examination, right? So for the Java and for this IA2 and for PC based instrumentation, for the these three subjects, you should be ready for submission of assignment and submission of this mid one examination, right? And see, already we know something about the basic concepts of PC based instrumentation, right? So under that we covered what is PC based instrumentation and what is the structure and what are the different devices available, different parts available, and explanation regarding this, right? Orally we covered, and this time we see uh, with a good explanation what is PLC and what is the structure and what is different supporting device available in this PC based instrumentation, right? Um, okay. Uh, right. We see. Right. In this programmable logic controller, so what is as you know that what is PLC? PLC is nothing but is a user-friendly microprocessor based specialized computer. Specialized computer. If we sound again, sound again, please. PLC is a user-friendly microprocessor based specialized computer that carries out control functions of many types and levels of complexity. So, in simple language, you can say it is a PLC is nothing but is a simple type of a computer. It's one type of computer. It's a microprocessor based computer. It's a simple computer. So that computer carries some control functions. It has some control functions. Okay. So what is the purpose of these control functions? Its purpose is to monitor the crucial process parameters and adjust the process operations accordingly. What it means? What it means? Generally, in the industrial instrumentation 2 or process control instrumentation, what you understood with the two subjects, in the industrial instrumentation 2 or process control instrumentation, the main objective is to measure the parameters available in the industries, that's called industrial instrumentation. To monitor the parameters in the industries, that is called to monitor and control. That is a subject of process control, right? So the PLC comes under process control. So PLC is not a separate subject. The PLC is merging of a process instrumentation, process control instrumentation. So in the process control instrumentation, we are monitoring and controlling the parameters. Okay, but in this PLC, the same we are going to monitor the crucial processes. There we are only up to some parameters, but here some processes we want to monitor and control and adjust some operations accordingly. So this is a specialty and what is called the more responsibility of this PLC. So the more responsibility of the PLC is it is going to monitor the processes are available in the industries. What are processes are available? Temperature control, pressure control, viscosity, pressure, forces, flow control, speed control, velocity control, isn't it? Velocity control, acceleration control, uh, maybe some mechanisms you want to monitor and control it, which are available in industries. So these are all comes under processes. All comes under processes. Okay, it will be physical process or chemical processes or other related processes. The process may be any one, but that should be monitored and controlled, right? And all these operations should be controlled with this programmable logic controllers. So this is the responsibility having with these programmable logic controllers. Okay, and how it is going to be done? How it is going to be done? See, how it is going to be done means, uh, see, so this can be done. Uh, this can be done by programming the a computer, right? So and it can be controlled and operated by a person. So we need a person who can control the operations of the PLC. He can do manually. That's what who is a PLC literature. So it means that you can do manually controlling the sections or sometimes automation. You can automatically can control all the processes because we have some set values, we have some the limit values. So based upon that, this PLC acting as uh, a human operator, as a human operator, automatic human operator, the automatic control system, automatic control system. So the main purpose of this PC-based instrumentation, PC-based instrumentation, it is instrumentation. We are using the instruments. We are using the instruments. That's called instrumentation. But the instruments are based on our computer. All the instruments are controlled based upon the computer programming. It is called a PC-based instrumentation. So in the PC-based instrumentation, the heart of this subject is PLC, programmable logic controllers. So programmable means it should be programmed. If you want to change one operation to other operation, one control to other control, or several controls you want to control at a time, we need programming. So without programming, it is difficult to control, difficult to monitor different processes and different operations in the industry. So for programming, we need a processor, we need a memory system, we need a keyboard, we need input output modules, peripherals, what type of supporting devices you need, all are needed for the PLC. So what type of supporting device you are using for a general computer, all are required in the PLC. So that we can program, we can monitor, and we can control the parameters at the end of the industries, at the industry levels, process industry levels. So the PC-based instrumentation is not a separate one, it is a merging of the process control. Merging of the process control. Right? So in the process control subject, you are controlling and monitoring with available instrumentation, some closed loop system. But the same closed loop is done in the case of PC-based instrumentation using PLC, using programmable logic controller. That is a simple difference between process control and PC-based instrumentation. Clear? Right. And see, how can you visualize this PLC? How can you understand, visualize this block diagram of this PLC system? So the PLC system, as you know, that it comprises the basic elements like, first of all, there is a CPU, central processing unit, which includes some memory. So because of this, we can program, we can interface different modules, right? And to the left of this, we have input model followed by the inputs we have to consider. You have to collect some inputs. 50, 50, is from the input side, we have input model followed by, the input are getting from these different fields, different industrial sensors. So from different industrial sensors, you have to collect the data, collect the inputs data input. That's called data inputs. So all the data inputs are collected, and by this input model, they are going to apply for this process. So what is this? This is called digital or analog input model. So you can connect the inputs in the form of analog manner, or you can convert these inputs into digital form before going to give to the CPU. That's about this. And one more, the right of the CPU is the output model. This output model we have. So this output model also be again a digital form or analog form. As per your requirement, you can give as output is analog or output is digital, right? So that output is given to the actuators or any load. Load means here maybe motor or any solenoids or any mechanism or any operations. So whatever the process you need to control, whatever the mechanism you need to control, what type of operation you need to control, that is, for that we have to give the output. So because of this output, all the actuators are functioning, all the motors are functioning, all the solenoids are activating and doing its function. So this is the specialty of this programmable logic controllers. Okay, and see in this programmable logic controllers we have uh, see we have other forms. How this relay can be done? How this logic is executed? How can you visualize? How can you know it is a logic? So it is very simple to understand. See, this diagram will give an idea about a logic and function. So here we have some the two members are attaching, and here the two members are providing some gap, right? And here there is a coil. There is a coil. It is a core. It is a magnetic coil. It is a magnet wound with the coil. Wound with the coil. And see, this is a normally open terminal. It is normally closed terminal. Normally closed terminal. So when it is going to be open and when it is going to be closed, that should be done with the help of available inputs. Available inputs. So there is a common terminal which provides damping with the help of a spring. With the help of a spring. So what this relay logic will tell us, what it describes actually it describes a simple mechanism. Simple mechanism means when the two devices are coming together, close, and when these two devices are open, so that is looks like a open and close mechanism. Open and close mechanism. So when it should be done, when this type of operation can be done, when this type of control can be done, means based upon the application of the input to the device. So here, if you excite the coil with some electrical current or voltage, it is magnetized so that initially it is open, now it is closed. Now it is closed. So when this is closed, some process is going to be done. Some mechanism is going to be executed. Right? So initially when no current is applied, when no voltage is applied, initially it is open. Initially it is open. When we apply a supporting voltage or current to this structure, to this arrangement, it is going to be closed. It will magnetize so that these two are closed. They will come contact together so that it is going to be moved. When the armature is going to be moved, there is a movement in the spring so that some solenoid, some mechanism is going to be executed so that it is going to be controlled some parameter in the industry. So without movement of armature, without the closing of the two, without connection here, no succeeding operation can be executed. So if you want to execute, if you want to perform any control operation, or if you want to monitor and control such mechanism, it should be done with the help of inputs given. Inputs given. Okay, that's about this simple relay mechanism. Okay, and how it can be done, this mechanism, what type of elements we needed, what type of devices we need. The devices are relay switches. The relay switches. See, the relay switches having some parts. No connection input. There is a coil. There is a common terminal, and is a no connection here we are going to use. So if you use this section, it acts as a relay. It provides some closing mechanism at some time based upon the voltage available. It acts as a open mechanism based upon the availability of the voltage. So it is nothing but a relay. And what type of relay logic panel board in a large scale. So how these relays are useful in very large scale industries. See, the diagram shows that very complex one. Very complex. It is very difficult for a human being to identify which relay is going to be operated, which relay is going to be functioning. So for all this relay panel is a complete board. On this board, there is a relay logic. So each relay logic can be controlled with a simple automation system. A control system or a computer, the available computer can control, monitor all this. So it can be done with the help of PLC. So, and similarly, see, is a PLC panel. How this PLC is going to be, how this PLC panel can be visualized. See, there are different sections of PLCs. Different sections, different models of the panels. These are called panels. These are executed by all these supplies. And see, these are given some control signals to other succeeding devices outputs so that it can control all these. And see, there is a person Manually is going to be monitored PLC panel board. So he is a person, he is a photo from Siemens company, right? There, there is a person operating with the laptop. So the laptop having some programming possibility. So these are all some, what are these? There are some different devices are connected. So with this available supply, the available section, he is going to program and monitor and control all the sections with a simple keyboard. Simple keyboard. So it's a simple panel board. We can program it, we can monitor it, or can control it all the sections. So it is available PLC. And what are the advantages of your programmable logic controller? What are the advantages? So advantages are they are very fast. They are very fast. Why? Because it is operated with some a computer. So no deviation, no delay, no delay. So if you press any button, there is output command. Based on the output command, the process is going to be executed. The parameter is going to be controlled. Uh, so like this. So based upon the buttons we are going to give, or it is automatic programming. So it is called fast, very fast. Easy to change the logic. You can change the logic. What type of logic you want? You want opening or close or any relay, or you want to solenoid, you want to movement, you want to move any member, or you want to press any bellow, pressing of bellows. So like this. So any movement, any logic we can control with flexibility. If flexibility means that flexibility is available with our computer. Our computer. And one more is reliable, reliable due to absence of moving parts. So with this computer PLC, there are no moving parts because it is completely programming. So complete programming. So because it is reliable, it is more reliable. You can and myself, you can easily operate this. And low power consumption. It needs some uh, useful power. No extra power is needed for this. And one more is it can easily maintain due to modular assembly because all PLCs nowadays are available in assembly manner. It's a ready-made food, like ready-made food. Just open it and eat it, have it. That's the meaning of this. So easily you can maintain due to modular assembly. Modular assembly. Ready-made kits are available. Ready-made models are available. What type of application you want? Based on that application, that type of PLCs are available in the industry, in the market. You can just buy it and use it. You can control as per your requirement, right? And facilities in fault finding and diagnostic. Suppose in the industry any problems occur, or in the PLC cell itself any problem rises, any fault, you can debug it. You can debug. Debug means bug means error. Debug means you can overcome the error. You can diagnose this. Okay, where is the problem? You can identify if there is a facility available in the PLC, right? You can overcome the problem. You can overcome the errors. That is a facility is available in this. And other advantages with this is good documentation facilities. Good documentation facilities. That is also an the other advantages in this is good documentation facilities. Okay, documentation facilities means you can document all this data, results, monitoring recipes, process, all the parameters. You can document possibility. capable of handling of very complicated logic operations. So this is specialty of PLC. We can handling very complicated logic operations. If we are treating their complex operations, we can handle very easy manner with this PLC. Easy to couple with process computers. So if you want to couple with other supporting computers like HMI SCADA system, we have a last chapter is SCADA. We see there what the meaning of SCADA. Supervisory control, supervisory control system we can have, right? And we have analog signal handling and closed loop control programming. So we can handle analog signals and closed loop controlling options. And we have a counter, timer, and comparator can be programmed. So we can program sequential programming. This is the meaning of this. We can program the counter, we can program the timer, we can program the comparators available. So accordingly with this. Okay. These are advantages. And next one is what are the operational sections of PLC CPU? In the CPU of PLC, what are the parts available? What are the operations you can perform? You can perform. As you know already in the last class also I can review all this, right? Yeah, see that. So in the CPU, in the processor, there should be logic functions, clock, and other extra operations you can do. And these should be executed by some power supply. That should be some building electrical AC power, or as usual power system, AC power, or this power, this operation, the CPU, they may have some input modules, input command keyboards, monitor, you can monitor it, you can connect the peripherals, and you can record the peripherals, and we can connect the output models to the CPU like this. And if required, we can have a battery backup also, right? And apart from this, we have a memory, fixed memory and alternative memory. In the fixed memory, we can have a ROM, read-only memory. In the alternative memory, we have a RAM. So with this ROM, we have some logic, edit options, monitor, communicate. So with this alternate memory, read and write, which is also called read and write memory, you can have some diagrams options, numerics, function status, IO status, right? All these functions you can do with this ROM, right? Next. So what is the internal architecture of the PLC? What is the internal architecture of the PLC? Okay, in this, if we open this CPU, we can have the three parts. You know, in the computer organization, the last semester CO subject, right? You are very well known about all this computer organization, basic diagram and operation of the all this, right? Once again, I am recalling you. See, in the PLC having some structure like this. So in this processor, there is, you know, some ROM and fixed operating system programming, right? And apart from this, there is a control unit, arithmetic logic units, and some resistors. Resistors are also having some flip-flops, right? All these are available in the control section. And there should be some analysis part. And this is connected to different models, input models, output models. With these input models, we can do some inputs. With the output models, we can have some control signals for controlling the parameters needed any operations, any devices in the industries. Okay, with this input section, we are collecting some control signals. I mean, with the input signals from the sensor. All the sensors are given to the scanning section. Scanning. So with this input model, we have to take some inputs. These inputs are scanned. We have to scan accordingly. What type of input? We have to convert the input. So with available keyboard, scanning section, logic section, right, like this. And after that, the same can be output can be scanned and interface to the other sections through some output models. Output models, right? And in this, and so as you know that in the previous slide, so there should be some input output models between CPU, between PLC, I mean between CPU, say for example. Yeah, in the first slide, what is there? Yeah, in the CPU, there should be input model and output model. So how can you collect the input? It is from the sensor. So how can you get output model from the CPU instructions, right? That is given to the actuators, motors, and solenoid. So what happens in between input and CPU, and what happens between CPU and output model? So it is nothing but scanning can be done. Scanning can be done. See the scanning. PLC scanning cycle, that is called PLC scanning cycle. So in the PLC scanning cycle, there are three parts operational cycle, three parts available. So in the three parts, input scanning and program scanning and finally output scanning. So all the parameters, all the inputs, programmed operations, and in the output, all the parameters are scanned because it is a programming section available in the PLC. So how it can be done? See the diagram. In the input scan, see input terminals in the input terminals. Yeah, input terminals are read and input status table is updated accordingly. So here updated input status table. Input status table. So this is the meaning of input scanning. All the inputs are collected and it is maintained as a table. That is called input scan. Okay. Then user program scanning. See, user program scanning. Program scanning means what happens here in the program scanning. During program scanning, data in input table is applied to user program. Here we have applied, and program is executed, and output table is updated, accordingly. This is called process scan detail, or program scan. So these are executed accordingly and maintain a table, output table. So it maintains some table. This one is maintains some table, this is input scanning. This one maintains some table, this is called output status table. And after this, based upon this table, we have some output terminals. So data associated data associated with output status table it is transferred to output terminals. So this is a cycle, PLC cycle. If input is given, that is maintained as a table, that's the input scan. Based upon this input, it is programmed and it is maintained as a table, that is called program scan. And based upon this table, it is maintained as other table, that is transferred to other sections, that is called output scan. So the three cycles are available in the PLC cycle. So input scan, program scanning, and output scanning. Remember, in the diagram, most of the sections will be done with the program scanning. See, we are showing maximum percentage. Program scanning is very important in the PLC. So it name as programmable logic controller. So program is very important for this module, for this PLCs. Okay, and see how this can be done. How this can be done means there are two ways you can done this scanning. Horizontal is also called row scanning. So it runs horizontally all is like this horizontal. Once it is scanned horizontal one line, it comes to other horizontal line. It is called rung. 1, 2, 3. It is called rung. How many horizontal lines? They are depicted as rung 1, rung 2, rung 3, rung 4, and so on. Once the last rung is over, it is called finished. It is started at the rung 1, it is finished at the last rung. So this is called horizontal scanning. It is also called row scanning. Row scanning. Otherwise, you can also do vertical scanning or column scanning. It is called run 1, 2, 3, 4. It is start vertically. It is called vertically. Once it is over, it comes to second one. Once it is over, it comes to third one. Column scanning. All the columns are over. It is called finish. It is called finish. It is called vertical or column scanning. You have to scan all the input models, programming, and output models. Okay, scanning. And what type of power supply it is needed? As you know that you can have see the diagram. You can have what type of diagram? Yeah, in this. I'm sorry. No. Power supply. Yeah, in this power supply, the power supply may be with the electrical AC supply, or the power supply may be with the battery. With the battery, the same I am depicted here. See, in this power supply, a line conditioner, line 1, line 2 ground from the power supply. It is called power supply, or with the regulator battery, or with the regulator battery. So you can use as per your requirement. You can use this power supply with the regulator. You can get also a fixed power supply. 5 volts if you want, you can use one IC. Minus 5 volts you want, you can use IC. What is the 5 volts? What is the 5 volts? In the if you have LDAC, I think this semester we have LDAC, right? Linear digital IC application. We have different ICs, operational amplifiers. That number of ICs are available, which converts the variable supply into fixed supply. That is called regulator. Using the GINA diode also you can convert it. Okay, that is called a negative. You can have a positive supply or negative supply with some fixed regulator. With a fixed that's called ICs, integrated circuits, or with some variable supply like conditioner. You can convert with some rectifiers. You can have some rectifiers. So it is a variable current or voltage. You can place a rectifier or rectifier with filter. You can filter waveforms. It is very. It is also very. Say here if you place a rectifier control, you can have this type of waveform. So in the EDC subject, we have these rectifiers and filters. So there should be a diode acting as a good rectifier, a filter, a capacitor acting as a filter. So with the diode and capacitor, you can have a pulsating DC. So it is variable AC. We have AC with constant. So this AC is called ripples. So we want to overcome this AC. How can you overcome? You can overcome with some filters. You can use a capacitor so that the AC available in this is removed, so only DC is allowed. So with the rectifier, we can have alternating AC into pulsating DC. This is called pulsating DC. In the pulsating DC, we have DC and AC. So if you use filter, AC is removed, only DC is allowed. So this is called DC waveform. Constant DC. No AC is available. That AC, DC is going to give for our PLCs. So you can use a backup system also, battery. You can use battery, you can use IC regulators, you can use filters and rectifiers. So these are all the power sections available. This power is useful for your CPU operating units. Operating units. Okay. And what is syncing and sourcing? Syncing and sourcing. Syncing means, yeah, syncing and sourcing of the I/O modules. So we are taking some inputs and outputs. We are taking some inputs and giving some input with the PLC. What is syncing and what is sourcing? Syncing means provides a path to supply common. So that is called syncing. You have to provide a path to supply common negative. You have to provide a path to supply source positive, that is called sourcing. This is the meaning of syncing. See, syncing input, a positive logic. How do you connect? How do you mean of syncing input, a positive logic? See here there is a supply and there should be input and common. This is called input and common. And here we are using input sensing. Input sensing. So this is the way you have to connect to the PLC. Connect to the PLC. This is called syncing input connection mechanism. And what is syncing output? Syncing output, syncing, syncing input and sourcing input. Sourcing input means the same mechanism. See, if you take this input sensing with this connection with negative logic, that is called sourcing input. Sourcing input. And here syncing output, negative logic. So with this, see, with this output switch, you have to connect a PLC, this connection with the load and supply. This is called syncing output connection. And sourcing output connection, positive logic. So see the arrangement, how the supply with PLC is going to be connected. So syncing means like this, with positive logic. This plus is going to give this input side. And here in the past, plus is given to a common, this is called sourcing input. And see, plus is given to a load, this is called output one, that's called syncing output. And this plus is going to a common one, that is called sourcing output. See this diagram, how they are going to be modified. This is the meaning of syncing and sourcing the I/O modules. Okay? Okay. Okay. This is about your. This is um, about your